In this video, we're going to be looking at the definition and the properties of a trapezoid. So a trapezoid is a quadrilateral, so it's a four-sided figure with exactly one pair of parallel sides. So let's write that down and then talk about it. So a trapezoid is a quadrilateral. Oops. And it's really important that we know that is exactly one pair of parallel sides. Not two, not zero, but exactly one. Okay, so here's what a trapezoid looks like. It looks like this. We have our parallel sides, and then we have the two sides that are not parallel. So the parallel sides, let's put a marker on them so we know that they are our parallel sides. Our parallel sides are called our bases. So we always have two bases for a trapezoid. We have base 1 and base 2, or we can just call them each base. And the non-parallel sides are called our legs. So we have two legs as well. Two legs, two bases. We also have base angles. So the base angle of a trapezoid is formed by the base, so by a base. So we have a base right here and a leg, and we have a leg right here. So in between, we have a base angle. We have another base angle over here between the base and the other leg, and we have base angles up here as well. So even though we always think of bases as the bottom, in this case the base is not necessarily the bottom. The base is our parallel sides. We could even have it sideways. So we could have a trapezoid that looks like this, and then, oops, let's make that straight. And in this case, because these are our parallel lines, the bases are on the left and the right, and that's entirely okay. All right, so now that we know what a trapezoid is, now we can start to look at a more specific type of trapezoid called the isosceles trapezoid. Okay, so if the legs of a trapezoid are congruent, then it is an isosceles trapezoid. Let's write that down. So what do I mean by that? Let's talk about that in just a moment. All right, then the trapezoid is isosceles. Okay. Oh, some of my letters got skipped there. There we go. All right, so in this case, we have a trapezoid. And you may recall from a couple minutes ago, this is a base. This is a base because they are parallel to each other. My little arrow is a little off, but there we go. And these are legs because they are the sides that are not parallel to each other. So in order for a trapezoid to be isosceles, or legs have to be congruent. They have to have the same measure. All right, a few things are going to follow from that, though. In addition to the legs being congruent to each other, or base angles will also be congruent. So that angle will be congruent to that angle. And up here, this angle will be congruent to this angle. So there are two pairs of congruent base angles. Not all of them will be congruent, but there are two pairs of congruent base angles, as we can see here. All right, something else that we need to know is we actually don't have to check to make sure there are two pairs of congruent base angles if we have our parallel sides. So if we know for sure it's a trapezoid, and we can tell that at least one pair of angles are congruent, then we'll know that it is going to be an isosceles trapezoid, and automatically it will follow that the other pair of angles are congruent as well. And finally, the last thing that we need to know about an isosceles trapezoid is the fact that the diagonals are always going to be congruent to each other. So this line right here and this line right here are congruent to each other. All right, so that is all we need to know about the isosceles trapezoid. Now we can actually try a question which involves everything we've learned so far. Okay, so here we have a quadrilateral that looks like it may be a trapezoid, but we cannot be sure until we prove that it is. So the question is asking us to determine if it is a trapezoid, and if it is, to determine whether or not it's isosceles. So you may recall that a trapezoid has what? Yes, exactly. It has exactly one pair of parallel sides. So we actually, in order to show that this is a trapezoid, we have to, or to figure out if it's a trapezoid, we have to determine if we have exactly one pair of parallel sides. And the best way, the easiest way to do that is to figure out the slope. All right, so it does look like AD and BC are parallel to each other. It looks like it, but we can't assume, as I just said, so we have to test it out. So let's figure out the slope of AD first. And our slope formula is y2 minus y1 over x2 minus x1. So let's go ahead and call this, and it doesn't matter which one you call x1, y1 or x2, y2, but let's go ahead and call this x1, y1, and this one x2, y2. All right, so now the slope of AD is going to be 0, that's a 0, minus 4, y2 minus y1, over x2, which is negative 1, over negative 3. Oh, sorry, over... So minus negative 3. There we go. Which gives us negative 4, and that is over negative 2. Or sorry, just 2. All right, which gives us negative 2. All right, so that is the slope of AD. Now we can go ahead and figure out the slope of BC. So I'm going to erase that because now we're changing what our x1 and y1 and x2 and y2 are. So let's say that this is x1, y1, x2, y2. So again, what we're trying to do is show that, or figure out if this line that we just found a slope for and this line that we're about to find the slope for is parallel to each other, or if they're parallel to each other. So let's go ahead and plug in for the slope of BC. And those are segments, so let's put that there. All right, so we have y2, which is 3, minus y1, which is 5, over x2, which is 3, minus y1, x1, which is 2. And when we do that, we get negative 2 over 1, which is just negative 2. As it turns out, the slopes are actually equal. And that means that these two lines, we can say definitively, are parallel to each other. All right, now we have to figure out if the slopes of these two lines are parallel to each other. Now I'm going to skip that step. They're clearly not parallel. However, if you are working through a problem, you have to show this step. You have to actually show that these two lines are not parallel. I will skip you to the answer here. The slope of AB, when you work it out, should be 1/5. And the slope of DC should be 3/4. So as you can see, these are not the same slope, therefore they are not parallel. So we have here one pair of parallel lines and one pair that is absolutely not parallel. And that's exactly what we need in order to show that this is in fact a trapezoid. So now let's turn the page and see if we can figure out whether or not it is an isosceles trapezoid. Okay, so now that we know that this is a trapezoid that we're dealing with, in order to figure out if it's an isosceles trapezoid, we can do this in multiple ways. But I'm going to go with the most straightforward way and just test to see if my legs are congruent to each other. So if AB and DC are congruent to each other, then it will be an isosceles trapezoid. So now I'm actually going to relabel these so that I can have an easy time. Let's call this X2, Y2. X1, Y1. And in order to figure out the length of AB, of course, I'm going to need my distance formula. So let's put that on the page. It's X2 minus X1 squared plus Y2 minus Y1 squared. Okay. All right, so the distance for AB, so I'm just going to write AB. Length of AB is equal to X2, which we know is 2 minus x1, which is negative 3, squared, plus y2, which is 5, minus y1, which is 4, squared. So simplifying further, we get 5 squared plus 1 squared, square root of that, of course, and overall we get the square root of 26. All right, so that's the length of AB. Time to check the length of BC. So again, I'm going to label this, and since this is already saying x2, y2, I think we can keep that as x2, y2. And I'm going to call this x1, y1. And now we can figure out the length of this line, DC, or CD, whichever you prefer. So DC is equal to the square root of x2, which is 3, minus x1, which is negative 1, squared, plus y2, which is 3 as well, minus y1, which is 0, squared. And when we simplify that further, we get the square root of 4 squared plus 3 squared, which is the square root of 16 plus 9, the square root of 25, which we can actually simplify further as 5. So here we have the length of AB, that's the length of one leg, and the length of the other leg is 5, and those legs are not equal to each other. And in order to be an isosceles trapezoid, the legs have to be equal to each other. So though it is a trapezoid, so we already said yes to that, it is not an isosceles trapezoid. All right, so I hope you understood.